Hello everyone. In this section, we are going to discuss about prime number problem. When the program is executed, it is going to ask a number. It will say enter a number. For example, user enters 7. Then it will say 7 is a prime number. For example, the user enters 10 here. Then it will say 10 is not a prime number. Let's discuss the solution through logic and pseudocode first. First question is, what is a prime number? So by definition, a prime number is a kind of number which is divisible by 1 and itself. Let's take an example of 7. 7 is a prime number. That is, it is divisible by 1 and 7. No other number can divide 7 other than 1 and 7 itself. If you consider 13, it also cannot be divided by any other number. But if you say 10, then it is divisible by 2 and it is divisible by 5 as well. So 10 is not a prime number. So if we look at this discussion, we can make out that the numbers which are not divisible by any other number, they are the prime numbers. This now we know, but how to achieve the same thing programmatically? Let's try to put few steps to check whether a number is prime or not. Consider 5 for example. If I want to check that 5 is prime or not, then first I will check, is 5 divisible by 2? Because 1 anyway can divide any number. So I'm going to start checking with 2, that is 5 divisible by 2. Now here I'm going to use a percentage sign even in the logic and even in the pseudocode, because percentage is a most commonly used operator known as the modulus operator, which returns the remainder. So modulus operator, the percentage operator, can be used to check the divisibility. So here the first question, is 5 divisible by 2? If it is not divisible, then for 2 it is prime, but I need to check till n minus 1. So what I will have to do is, I will check, is 5 divisible by 2? No? Good. Then I will check with the next number, is 5 divisible by 3? No? Good. Is 5 divisible by 4? No? Then only it is a prime number. It means starting from 2 to n minus 1. In this case, the number is 5. We have taken example of 5. So we are going to check till 4. So starting from 2 to n minus 1, if no number can divide, then only it is a prime number. So this means we will have to put a loop which starts at 2 and ends at n minus 1. Assume that this n is 13. That means from 2 to 12 you are going to check. Of course, you can reduce the number of repetitions, but that we are not discussing at the moment. We can improvise the coding, but that we will see at a later stage, where we can reduce the number of repetitions and the code can execute faster. But right now, fundamentally, when you check about prime number, you start with 2 and go till n minus 1. Let's try this with pseudocode for value 5. We consider variable n which has value 5, and n is the variable which we want to check whether it's prime or not. We are going to put a loop using a variable called counter, which will begin at 2 and it will go till 4. That is actually n minus 1, and step will be 1. That means every time it gets incremented. Because we need to check whether n is divisible by counter, we are going to use an if condition. So ideally you may think of writing something like this: if n modulus cnt, that is if it is divisible, then it is not prime. And if it is not divisible, in the else part, you will say it is prime. So ideally when you run this, n will be 5 and counter is 2. So is 5 divisible by 2? It is not. That means it will say it is prime. But if you put this inside the loop, the code will not work the way we are expecting. Let's try to run this practically here on the page to see what will be the issue. So 5 modulus 2, it will say it is prime because it is not divisible. Now counter will be incremented by 1, so counter will become 3. Is 5 divisible by 3? No, it is not. Again it will say prime. The counter will become 4. Is 5 divisible by 4? No, it is not. Third time it will say prime. So you wanted that it should show prime only once. Let's take an example of number 6. So now your loop will run from 2 to 5. Is 6 divisible by 2? It is. So it will say not prime. Counter will become 3. Is 6 divisible by 3? Yes, it is divisible. Again the message will be not prime. Now the counter will become 4. So is 6 divisible by 4? No. So it will say prime. So if the number is 6, sometimes it will say prime and sometimes it will say it's not a prime number. That is something which we do not want. What we want is that from 2 to 5, no number should divide this given number, then only it is a prime number. In such case, what you can do is you can take an additional variable. In programming, this is called as a flag variable. You can name this flag variable whatever you want to. But this flag is going to keep some status. It is going to store some value that will determine at the end whether it was prime or not. You can name this flag variable anything, right? You can name test or anything you want to. That doesn't matter. What matters is the concept of flag variable. Whenever we say it's a flag variable, that means it's a kind of variable which is going to keep a state for certain things. So here, let me take a variable called is prime. Now, in various programming languages, you have data type called Boolean where you can keep this true or false. But at the moment, because we are writing pseudocode and we do not want to deal with complex data types here, let's say in is prime, I am going to say 1. That means I assume from the beginning that the given number is a prime number. You can assign the value you want. Let's say you decide that 6 means prime and 7 means not prime. It's fine. But we are going to take 0 and 1. 1 means we are going to consider it as a prime number. So now what will I do? If the n was divisible by counter at any point of time, that means it is divisible like this, then I'm going to assign value 0 in prime. Not only that, now because one number could divide that, I do not want to continue the loop. I will come out of the loop. So I will say exit for. In the language, in the programming language term, you are going to break the loop. But because we are writing pseudocode, I am trying to write simple English language. So here, once the number, that is the n, was divisible by any value of the counter, that is from 2 to n minus 1, any number could divide. That means I'm going to assign is prime is equal to 0 and then I'm going to come out of the loop, because now it is decided that the number was divisible by some number, and because it was divisible, it is not a prime number anymore. So now after the loop is over, the only thing you will have to do is you'll just put a condition. If is prime is equal to 1, then you will print that number is prime. Else is prime value is 0, then you will say number is not prime. So the loop is very simple to understand, but you need to understand the concept of the flag variable. Flag variable is a kind of variable you use to keep the status of the situation. Here the situation was it was divisible, so you made it 0. Let's try to code this. I'm going to take similar variables here. Let's say we'll use variable n, where we are going to get the data. So I will say prompt here and enter a number. We'll also take a counter. Of course, we can put this in a for loop only. So I will say for loop, let counter is equal to 2, counter less than n, right? I don't have to say counter less than equal to n minus 1. I can say less than n. So if n is 5, it will go till 4 only, and counter plus plus. Let's try the first way, where it is going to show me prime or not prime, both the things. So I'll just put an if condition here, where if number is divisible by counter, that means it is a prime number. It's not a prime number. Not prime. Else it is a prime number. Let's run this. I enter 5 here. It says prime 3 times. As you can see, there is a counter. Let me type 6 in this case. So it says not prime 2 times and prime 2 times. Right? This is the problem. So we took a flag variable. Let me take is prime. Now JavaScript has Boolean value. So I'm going to say is prime true. So from the beginning, I'm assuming that the number is a prime number. Now when this was divisible, that means any number could divide, I'm going to say is prime is equal to false. I'll make it false, and of course I'm going to come out of the loop because I do not need to check more iterations like this. And outside the loop, I'll put a condition that is prime is true. Then I'll display a message saying that n is a prime number. Else n is not a prime number. Let's try to run this code now. I'll say 5. It says 5 is a prime number. Let's try 6. It says 6 is not a prime number. Let's try 13. 13 is a prime number. I'll say 21. Say 21 is not a prime number. In short, you check the prime number possibility with this kind of logic. Remember, even if you repeat the loop till n by 2, then also you will get the correct answer. Say for example, you have value 100. Then you need to check till 50 only, because by the time, if it is divisible, some number will divide. This is to reduce the iterations and to execute the code faster. But at the moment, we do not want to improvise on the prime number logic, or we do not want to make it more perfect. We just want to target that we understand the logic and we try this simpler code of finding a prime number.